Hello and welcome to Starfish Maths. My name's Sarah and today I want to go through the binomial expansion. I'll show you two slightly different ways of doing this and 5 examples, slowly increasing in difficulty. Please, as always, join in with a pen and paper, pause the video and have a go yourself and come back and compare. I hope you find this helpful. Let's get started. I want to start by explaining this notation here. Now you might have seen this before. This Ncr actually means how many ways there are of choosing a number of objects. So if we've got, for example, 5C3, that's if you've got 5 objects, and this will work out how many ways there are of choosing 3 of them. Now, it's worked out using this formula here with these exclamation marks. They're called factorials, and they mean timesing all the way down to 1. So we'll have n factorial on the top, so here that will be 5 factorial. And what that means is 5 times 4 times 3 times 2 times 1. That will be over r factorial, which here is 3. And n minus r will be 5 take away 3. Okay, so that 3 factorial is 3 times 2 times 1. 5 take away 3 is 2, so 2 factorial on the end is just 2 times 1. Now we can do some cancelling. So we'll have 20 on the top and 2 on the bottom, giving us 10. Have a go at working these ones out yourself. Pause the video and come back and compare. Okay, well done if you got those ones right. Now the whole point of practicing those is you can use them when you expand a binomial. So here's a binomial, our first one to look at, and the first thing we need to do is get the coefficients. Now there's 2 ways of doing that. You can either use this Ncr that we were using just now, or you can use Pascal's triangle. Now let's look at both and you can decide which you prefer. Of course, you do need to be aware of both ways. You might be asked specifically for one of the 2 ways, so it's good to know both. Let's look at the Ncr notation first. We're going to look at the power here, that's 4, and it's going to go up 0, 1, 2, 3, 4. So we'll start 4C0. Now they're the number coefficients. And of course you can work those out using the formula that we just did. So do go ahead and do those. I'm not going to bother doing them just now because I want to show you the other way of getting those numbers, and you can check that you've worked out these ones correctly just by comparing them to this Pascal's triangle. Now Pascal's triangle is one of those things in maths I absolutely adore. It's brilliant. You might have seen it before, but you might not have seen all the different patterns that you can find in it. It's amazing. So Pascal came up with this triangle but didn't realise all the hidden amazing things that it had in it. If you've not seen it, do Google Pascal's triangle. Let's have a look. It starts with 1 at the top, and you get 1 going down each side, so we start and end each row with 1, and we get the middle numbers by adding the previous 2, so 1 plus 1 is obviously 2, start with 1, 1 plus 2 is 3, 2 plus 1 is 3, and end with a 1, carry on the same way with that row, and as you go down, just really quickly, one of my favourite things in this triangle is if you look at the rows, they're actually the powers of 11. So 1 is 11 to the power of 0, 11 is 11 to the power of 1, 121 is 11 squared, 1331 is 11 cubed, and that's just mad. It's got nothing to do with Pascal's triangle. You wouldn't think that was related, but it is, and it's just amazing. Do Google it. Anyway, back to binomial. So if you want to use these numbers, it's a really easy, quick triangle just to draw out at the side of your exam paper, and these numbers are actually these ones. So it's good to know the formula to get these, but also you can use Pascal's triangle. So the top row is row, sorry about those noises, that's my dog. The top row is row 0, the next row is row 1, 2, 3, 4. Now because we've got the power of 4, we want the 4th row. So there are those numbers there. So actually if you go ahead and use the formula to work out these numbers, you should get that they are 14641. Do check that. It's good practice, but as I said, it's good to know both of those ways. Okay, so that's the first step, is getting these numbers either by using the Ncr notation or using Pascal's triangle. The second step is to take the first term and put some powers on it. So let's start with 4 and go down. 4, 3, 2, 1 and 0. The last step is to take this term here. I'm overlapping there because if that was a minus, you would need to include that with the term. But this is a positive 2x, so that's okay. Now, these ones need to go in the opposite direction. So if that term's going in descending powers, these need to go in ascending powers. And the most common way they like it in the exam, they often specify, they often say they want it in ascending powers of x. So we'll start with 0 and go up. Okay, now we need to collect all this stuff together and simplify it as much as possible, which is, I enjoy this process, but obviously there's loads of places you can make mistakes, especially if there are some minus signs, so do pay really close attention. Just making one mistake in one term will lose you a mark. You can lose up to 2-3 marks here if you're not paying close attention. So we're going to times all these things together, and I've put pluses in between each term, which is something you can always do. So let's work them out. 1 to the power of 4 is still 1 times 1. And then anything to the power of 0 is also 1. So here we've got 1 times 1 times 1. So we're safe to say that term is 1. Now here we've got 4. We've got 1 to the power of 3, which is 1. And we've got 2 to the power of 1 and x to the power of 1. Don't forget that you need to raise both of these things to the power. So 2 to the power of 1 is 2 and x to the power of 1 is x. We'll come back and simplify that in a minute, but let's move on for now. We've got 6 times 1, and then we've got 2 squared, so that's 4, and x squared. 4 times 1, 2 cubed is 8, and x cubed. And then 1 times 1, 2 to the power of 4 is 16. I hope you can read that okay. Now let's simplify those up. And there you have it, that's that binomial expansion done. Let's do another one now and use either the C's or the Pascal's triangle, it's up to you. We'll do 2 more examples of this, so it might be worth doing one way and one the other. Okay, if you pause the video, have a go at this yourself and come back and compare. Okay, I hope you got that right. Well done if you did. There's a few potential places to trip up. One of them, the big one, was the minus sign. So do keep that minus in the brackets there. I did make a mistake on the last one. If you spotted, I put the cubed before the brackets. So you need to protect everything in the brackets before you put that cube power on. Also then, when you've got the minus here, don't forget to make that minus and that one minus as well. Well done if you got that. Let's do another one. Okay, so in this one, we don't even need to do the whole thing. We're only asked for the first 4 terms. That's quite a common thing to be asked for in an exam. But make sure you're aware that it's in ascending powers of x. So if you did descending powers, you'd actually get the wrong 4 terms. So do have a get this, pause the video and come back. Okay, again, well done. Very well done if you got that one right. There are places you can make mistakes with arithmetic, with minor signs, so well done. Okay, in this one we're only asked for 1 coefficient, so it's just 1 term we're interested in. Again, this is a really common kind of question in an exam. I think the best way to approach this is to use the C's. So to use the C's, it will be 5C3 for that one. 2 term will be to the power of 2, and the other term will be to the power of 3. Now the reason I know that is we've been asked for the coefficient of x cubed, so that one has to be 3. Now you might have noticed in the other ones, actually the powers of the 2 terms always have to add to be that power there. So 2 plus 3 is 5. That's how I know that one's got to be 2. This one here can either be 2 or 3 actually. Both will give you the same answer because they're symmetrical actually. Now we've been asked for the coefficient, and that just means the number, that bit that will be in front of the x cubed, so that will be all these numbers here. So it's just, the answer will just be the number, which I make it out to be 2,560. Okay, last question. Have a go first at part A and come back and compare. Okay, I hope you got the same as me there. It was quite big numbers, so well done if you got those calculations. I'm just going to write the answer further up so I've got more room. Okay, do have a go at part B yourself. It's a little bit trickier, a bit more problem solving. We've got we're trying to find this bracket times this one. Now this one we can write as the expansion we found in part A, so we use part A and part B. Now to find the coefficient of x, that's going to come by, if you times this bracket with this bracket, so times all the terms together, if you do 3 times the x term, that will give you a number with x, that will give a coefficient of x, and also this term times 64 will give a coefficient of x. No other combination will give x, it will either be just a number or a different power of x. So those two are going to give us 4,416. So let's work those out. 3 times 960 is 2,880. I did just use a calculator just now, I'm not a genius. And then we'll have 64 times cx. Now, we're only interested in the coefficient of x, so that will be that. I'm just taking off the x because we're just looking at the coefficient, and we know the coefficient is 4,416. So now we can solve that to get C. Okay, and I get 24. Very well done if you got that one right. Do keep practicing them. That was just some examples of exam style questions, but do have a look through the past papers to practice binomial expansion. I hope that was helpful. Thank you so much for watching and have fun.